In this video, we're going to simplify some problems with exponents. Let's take a look first at number 14. That looks interesting there. So number 14, what you'll notice that's different from 11 through 13 is that our exponent is given in decimal format. Well, it actually would be easier if we convert it into a fractional exponent, so let's go ahead and do that. This is the same thing as saying 27 over 8 to the power of negative 1.5 is 3 over 2. Now, based on what we know about our laws of exponents, a negative exponent technically means we should do its reciprocal. So I'm just going to flip 27 over 8, turn into 8 over 27. And that's to the power of now a positive 3 over 2 because we have already flipped our fraction. From there, one thing we also know is that if you have a parentheses here, along with an exponent, we can distribute that 3 over 2 to each of the terms. So this is the same thing as saying 8 to the power of 3 over 2 over 27 to the power of 3 over 2. Let's simplify that a little bit further. Now keep in mind that 8 to the power of 3 over 2, the 3 over 2 can be broken up into two parts. One, the over 2 is the same thing as saying square root. And then to the third power means what we have is 8 times 8 times 8, like that. On the bottom, what we have is 27 to the power of 3 over 2, where over 2 again means square root, and then 27 to the third is what's going to be put inside the root. And then we can simplify. One thing we know about roots, more specifically square roots, is that you're looking for groups of 2. So there's a group of 2. In fact, I think I should actually break up the 8 a little bit more. That's technically the same thing as 4 times 2, or 2 times 2 times 2. And then now we have another group of 2, so we'll be able to take that out. Similarly, on the bottom, we have a group of 2 27s there. We'll take that out. And then 27 can be made up of 9 times 3, or again, 3 times 3 times 3. Look for your groups of 2. There it is, 3, and take that out. So, as a final result, what we got here is we can take out 8, we can take out 2 from the top. That'll give us 8 times 2, or 16, square root of whatever's left over. What's left over? Just that solitaire 2. Over, on the bottom, we have 27 times 3. 27 times 3 is going to give us 81. And then you have square root of 3. That doesn't look right. One thing that we had learned before in Algebra 2 is that you cannot have roots on the bottom. It's better to what we call rationalize the denominator. So how do we do that? You multiply top and bottom by that root, in this case root 3. What do we end up getting? 16 square root of 6 all over, and then this will give us 3. That's how we rationalize the denominator, and 81 times 3 will give us 243. There we go. All right, let's go on. Number 15 through 17, write using one radical. Let's do number 17. That looks a little bit more on the complicated side compared to 15 and 16. So in number 17, if I do want to write using one radical, then what I notice is that technically I have different radicals. This is going to be a 10th root, and this one is going to be more like a 5th root, right? We have a 5th root here. So that's not going to work. We need one radical. If we need one radical, let's see what we have here. 10 and 5, they look like they have something in common, don't they? Well, x to the power of 1/10 can stay the same, but if I have 1 over 5, I know I can rewrite that technically as negative 2 over 10. And in doing that, now I've actually turned it into a radical of or rather a 10th root, right? That's its radical. So now they actually have a common radical. All right, well, let's simplify this. X to the power of 1/10, that stays the same. Nothing much we can do with that. But if you have a negative exponent, that's the same thing as multiplying by its reciprocal. So 1 over y to the power of 2/10. Okay, and then combining all that together, what we have is x to the power of 1/10 over y to the power of 2/10. Now notice here that they both have the same radical, right, over 10. So what we can do is treat this as x, the 10th root of x rather, over, and then this is the same thing as the 10th root of y squared. Okay, and if we want it as one radical, a property of radical says we can put it all together as x over y squared. There is our final result, like that. All right, let's bring that into this box that you see here. In general, what does it mean to have x to the power of 1 over n? We have gone over a couple times now in this video that this basically means that you have the nth root of x. What happens if you have an improper fraction, or a proper fraction for that matter? What if that has an a value in there, right? What does that mean? Well, technically, x to the power of a over n can be rewritten as x to the power of a, and then that to the power of 1 over n, right? That's just multiplying our powers together. Or, alternatively, we could have had x to the power of 1 over n, and then multiply that, take that to the power of a. Okay, well, if that works, then what is that really the same as saying? Well, think of this as the nth root of x to the power of a. And this second case is the same thing as saying the nth root of x all to the power of a. They both mean the same thing. Okay, so these are equivalent as well. When will this give you an imaginary number? Well, you know you're going to get an imaginary number, and I guess the simplest case we can think of is that the imaginary number is thought of as the square root of -1. So what do we need? We definitely need a negative inside that root, right? So the x value definitely needs to be negative. X has to be less than 0. What other cases do we need? Well, if we have the square root of -1, does it work also if you have the cube root of -1? No, that actually gives you -1. So when do we get imaginary? When you have a square root. That's when. Oh, that basically means that the root has to be even. Where's the root? Oh, that's the n. The n has to be even. Okay. Well, what happens if you have a more complicated situation where you also have an a value? Well, keep in mind that x is negative. You've got a negative number in there. You've got a square root. You're taking care of that. But what must that a be? Well, you need to maintain the negative value that's in there. So the only way you can maintain the negative value is if a is, hopefully what you're thinking is odd. If a is odd, then x will maintain its negative value. All right, let's take a look now at 18 through 20. Maybe it looks like what we're dealing with here is kind of going over that box that we just did. 18 and 19 look like something you can manage. We'll do that in class. But number 20, let's do that one together. All right, so what this is saying is -16 to the power of 3 over 2. What does that mean? Well, remember that negative can be broken up. This is really the same thing as saying -1 times 16, and all that is to the power of 3 over 2. Well, using laws of exponents, this is the same thing as saying -1 to the power of 3 over 2 times 16 to the power of 3 over 2. All right, what does the over 2 mean? Remember that merely means the square root. So you really have the square root of -1 to the third power. And over here what we have is the square root of 16 to the third power. What does that mean? Square root of -1 is the same thing as I. So you have I to the third power. And here square root of 16 is 4, so you have 4 to the third power. What's 4 to the third power? That's going to give us 64. What's I to the third power? That's I times I times I. Well, we know I times I squared is -1, so that's going to give us a negative. But then we have a solitaire I, so we're left with an I. That'll give us -64i then. Okay. All right, let's take a look at some more problems here. Let's do some equations. Actually, let's save equations for the next video. We'll stop here.